Okay, yesterday I was trying to get you to find the slope from an equation, meaning put that equation into y equals mx plus b form. And to do that, you have to move terms away from the y. Get all your terms to the other side so that y is left all by itself. And when you have y all by itself, you have y equals mx plus b, and m is the coefficient of x. It's the number that goes with x, and that's your slope, also known as rise over run. So one of the things I mentioned was keep your slope as a fraction. So say, I think the example was slope was 3 over 2. Don't turn that into 1.5. And this is where it's going to be a little more clear. Let's say you have two lines that look parallel, but you're not quite sure because they could be off by such a minute amount that eventually they'll connect somewhere way off in the distance if these lines are extended forever. So the only way to know for sure if that's going to happen, if they're going to connect somewhere off the page, is to check the slopes. And if the slopes are the same, then they're parallel. Right? That's the whole key to seeing if two lines are parallel. You have to check the slopes, and equal slopes means parallel. Equal slopes means parallel. And the symbol for parallel is two straight lines like that. So equal slopes means parallel. All right, let's check and see if these two lines are parallel. To check the slope of any given line, you just have to see how far do you rise, how far do you go up, and how far do you run, how far do you go over to get from one point to the next. So you need 2 points on your line. It could be any 2 points. I put points right here on the axes so it's easier to see where exactly those points are since this isn't graph paper. I just used the axes. So let's check this line up here first. You've got the point at -1, 0, and you've got a point at 0, 2, here and here. This one here, you have a point at 0, -2, and you have a point at 1, 0. So to get from this point, the -1, 0, to this point, the 0, 2, you would have to go up 2 spaces, up 2, and over 1. Up 2 and over 1. To get from 0 up to 2, you have to go up 2 spaces. To get from the -1 over to the 0, you have to go over 1 space. Rise over run. 2 over 1. Let's check this line. You get from 0, well, let's go up first. How far up do you have to go to get from this point to that point? You have to go up 1, 2 spaces, and you have to go over 1. So it is the same slope. To get from -2 up to 0, you have to go up 2 spaces from -2 to 0. And to run, to get over from 0 to 1, you have to go over 1 space. So rise over run, another way to say that is, you may not have seen this before, delta y over delta x. So there's a new symbol for you, a triangle. It's called delta. Someday when you're in college, you're going to see sororities that have Greek letters in them and fraternities, and delta is one of them that they use. It's a triangle. But what it means is the change, or how much does it change. So the change in y is your rise. So the y direction is the up and down direction. The y-axis goes up and down. The x direction is the left to right. The x-axis goes left to right. So what is the change in the y direction? What is the rise? It's 2. You had to go up 2 spaces to get from one point to the next. And what was the change in the x direction? 1. So 2 over 1, so they both have the same slope. Therefore, these lines are parallel. And you could say, if the question was, are these lines parallel? Your answer would be yes. Now, you're not always going to be given lines on a graph. Sometimes you'll just be given the points. So let me show you that. I'll use the same points. Let's just say line A, or line 1, they give you points A and B, and those are -1, 0, and 0, 2. And then line 2, points C and D, we'll call those 0, -2, and 1, 0. Okay, you may recognize these. These are the exact same points that I just gave you. So there's two ways to go about figuring out if the line that connects these 2 points. So that's what this means. Line 1 means it's a line that connects these 2 points. So all they're doing is giving you 2 points on a line, and you have to figure out the slope that way. So there's a couple different ways that you could figure out slope in these problems in this standard. One of them is the way I showed you yesterday. They could just give you an equation, and you have to figure out the slope from the equation. Another way is they could give you 2 points on the line, and you have to figure out the slope between those 2 points. So that's what I'm trying to show you now. And there's a couple different ways to figure out the slope between these 2 points. One of them is to graph those 2 points, and then you're right back to here. If you were to graph -1, 0, and 0, 2, which is what you've got here, -1, 0, and 0, 2. If you graph those, then you can just count like we did. Well, you have to go up 2 and over 1. So you can graph and count. That is probably the easiest way, as long as these numbers are small. If they give you like 20, 35, the point 20, 35, that's going to be hard to fit on a piece of graph paper. All right, so when you get big numbers, you're probably going to have to do this other method that I'm about to show you now, which is to find the change in y and find the change in x. So let's look at rise over run. Rise is the change in the y direction going up and down, which is your second number. Remember, an ordered pair is an x, y coordinate. So the second numbers in your ordered pair are your y distances. So what's the distance between 0 and 2? 2. There's 2 spaces in between 0 and 2. How many spaces are in between -1 and 0? 1. So your rise over run is 2 over 1. That's your slope. All right, it'd be the same thing here. The distance between -2 and 0 is 2, and the distance between 0 and 1 is 1. So you're going to have problems like that in today's do section, where they just give you a couple points and say there's a line that connects those 2 points, find the slope of that line. Then they'll give you a couple more points, find the slope of that line. And then you say yes or no, are those slopes the same or are they different? If they're the same, then yes, those 2 lines are parallel. If they're different, no, they are not parallel. So there's your second lesson on slopes. Lesson 1 is, if you're given an equation, put it into y equals mx plus b, and m is your slope. Lesson 2 is, if you're given 2 points, find the rise over run by the change in y over the change in x, or just graph them and count.